Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be talking to you about integrals and exactly what they mean. So let's begin. Now, some time ago, I published a video called The Mean Value Theorem Proof Explained, and I showed you quite a few things about it. But in this video, I'm going to start at the beginning. What does the word integrating mean? Okay, and I'm going to show you that mainstream mathematics professors have never understood integration and still don't have a clue. Because look, if you look up the word integrating, the definition is indicating the mean value, which is an arithmetic mean, by the way, or the sum total of a measured quantity. Now, let me just tell you that a mean value is not the same as a sum. So, I mean, if mainstream academics understood this fact, they would have known that an arithmetic mean is not a sum. And they would have understood that an integral is a product of arithmetic means. Okay. So, and I showed that very neatly in a video that I produced some time ago, this video here, where I revealed to you that it doesn't matter how you move a particular area about the mean, that all that will change, basically, all that will change is the interval width, but the arithmetic mean remains the same, okay? Why? Because all these are parallel to each other, right? So, and the only time that you don't use the arithmetic mean, well, you actually are using it, but not directly. So somebody says that there is no primitive or antecedent function. Well, you're still calculating an arithmetic mean there, but you're not doing it through the primitive function. You're doing it through numeric integration. Okay. So mainstream academics have never understood that. And that's the first thing I'd like to point out to you. The next thing is that, and by the way, and a proof of this that they didn't understand is given in one of the comment section here, where a German professor comes up and says, that works for functions when you know the primitive function. But what do you do when one can't write down the primitive function explicitly? So I answer him, and he comes back again. He said, he still doesn't understand. I mean, the guy's an absolute moron. But it's pretty clear. I mean, even a high school student can see from this diagram that I use in that video that f of x is equal to log of x is the primitive function of 1 over x. Okay, so that was what I tried to point out to him, but he still doesn't see it and still doesn't understand that the integral is a product of arithmetic means. So let's move on then to the next point. There's something that most of you don't know because your moronic professors don't know. And it's basically that a line integral, that all integrals are line integrals. So how does that work? Well, you see, when you work with line integrals, what you normally deal with is something like this. You take the square root of dy dx all squared plus dx, or rather make that dz, dy dz dx dz squared plus dz dz squared. Okay, and that's for a surface. But when you're looking at a standard line integral, what you normally see is something like this. You see this. Okay, you see that. But now what's hidden inside there for a standard integral is the fact that you're still using this particular approach where you have a scaling factor. Okay, scaling factor. That's all that this is. And you'll say dy dx squared plus dx dx squared, right? So for example, if you have integral of dx like that, you don't normally see what's inside here, but inside here, this thing here is hiding. Dy dx is just 0 squared, okay? And dx is just 1 squared. which means that this here is equal to 1. So you don't see the 1 in there, but this is inside there. And the standard definite integral is a line or contour integral. Okay. As a matter of fact, all integrals are contour integrals or line integrals. Doesn't matter if you've got a curve like that and you're finding a curtain over it like this. It's the same as the standard integral. So the point that I'm trying to make here is that if mainstream academics actually understood integration, which they never have, but it somehow seems pretty evident that they never had, because look at the definition. It says indicating the mean value or a total sum. So it seems that there may have been some feeling that the mean value has something to do with it, but actually it's got nothing to do with the total sum. It's the mean value theorem at work here, okay? And also when you do not have a primitive function, the mean value theorem is still at work. You're still finding an arithmetic mean of the y-ordinates and multiplying it by the interval length, okay? So now, the next thing I'd like to make a note of is that there's this idiot in Virginia called Michael Penn, and he produces these shorts. And so in the short here, he actually copied what he saw me do, but he doesn't understand. Look what he says here, fundamental theorem of calculus, and he writes it down like this, by the way. And what he's saying there is that you can think of this as a Riemann sum, and then just use the mean value in it. But really, the mean value theorem, and this is the idiot, the mean value theorem is what is doing all the work there. Okay. Now, I'll explain that to you in a moment. Let's go to an article that I wrote some time ago. Now, many decades ago. So basically, Riemann was a very mediocre mathematician, and a Riemann integral shouldn't even be called the Riemann integral because it's based on quadrature, which was understood thousands of years ago. Okay, and what Riemann was doing was saying, let's take the sum of many mental block, many rectangles, and then that will approximate the area under the curve. But that's actually the same as taking an arithmetic mean. And in this article, to which I'll place a link, I'll show you how that actually works, okay? So because it can be better defined as the product of two arithmetic means. All you do is you take out the dx, and then all these ordinates in here will be the sum. And of course, ultimately, you are dividing by, let me just copy that. Ultimately, you are dividing by n, so you are getting an arithmetic mean. You do have an arithmetic mean. Let me show you how. So let's clear that. New. Okay, so if you say this, let's just paste that over there like that. So if you say that, then this guy here is just b minus a over n. So we just move the n across here, and that, by the way, is an arithmetic mean, okay? So Riemann sum shouldn't be called Riemann sum. It should still be called the product of two arithmetic means. Now you'll say, well, if it was there, then how is what I'm telling you important? It's important because your moronic mathematics teachers and calculus lecturers and everybody else didn't tell you this. And it's pretty important to understand why you can actually integrate functions and get correct results, and even why numeric integration works, okay? So for example, if you're doing a Simpson's approximation here, it also, at the end of the day, boils down to a product of arithmetic means because it's approximating rectangles which in fact do have an arithmetic mean, okay? So leaving that aside now, the final part is how beautiful the new calculus is, okay? So the new calculus, let's go to it. The new calculus, and on page 130, I'll give you a free ebook, which I'll give you a link to. It's on academia. It shows you everything you need to know about integral and how beautifully this integral is a product of arithmetic means, okay? And notice, by the way, there's no bullshit there about limits like you find in this idiot short here. So let's just stop this. I don't know why this is happening. Let's just do that. Stop. Okay, let's just, there we go. Okay, so over here he he does this. You see, he's canceling out the ordinates, but that's just a cheat way of doing what I'm doing. A cheat way, okay. So in my, and of course he copied it from me. So this this article, this ebook, in fact, it's not an article, it's an ebook, shows you how you can arrive at the correct result of the mean value and prove it without the bullshit of there is a c in an interval b minus a, which is unremarkable because it's true for all smooth functions. And of course, the mean value theorem has been stated unremarkably since it was first published. But I corrected that. And in my free ebook, I show you the how beautiful the new calculus integral is. So if you want to find arc length, you just use the distance formula and watch how beautiful it collapses into the final form. There's nothing there about limits, by the way. Okay, nothing. You don't use limits or infinity or any garbage, and it still gives you the right result because the new calculus is based on well-formed concepts. So this document here tells you a lot about the new calculus and how you can use it. But if you want to learn much more, you have to buy my free ebook. Okay, not my free, you have to buy my book. It's not free. And it's called What is the New Calculus? Okay, it's only $9.99, which is a cheap price. You can get it on Amazon, and depending where you live, you'll have to go to one of these sites to purchase it. So that's pretty much it. I don't think I have anything else to add. I'm John Gabriel, and before I finish off, let me summarize. Just looking at the definition of the word integrating shows you it's proof that mainstream academics never understood the mean value theorem, which is the fundamental theorem of calculus. Remember, I showed you that in many videos before. Let's just do that quickly again before I sign off. So here's a statement of the mean value theorem. Okay. Like that. So the mean value theorem says that the area is this, okay, and this is equal to x plus h of the derivative, okay, not the primitive function, of the derivative. So this here is the derivative, not the primitive. And this here, so this, the mean value theorem identity and the fundamental theorem in one step. All you do is you multiply both sides by the difference, which is h, okay? And you'll see this in many forms. It's written as fb minus f of a over b minus a. It doesn't matter, they're the same things. So if you're not already a subscriber to my channel, click like, subscribe, and you may also want to join my members only, where I reveal a lot more than I normally do. Finally, there is a Discord new calculus where you can join, and if you pass a test, you'll have access to all the channels, which means a lot of yummy information that you've never seen in your life before. But otherwise, you'll only have access to 2 channels where you can ask questions or the lobby. I'm John Gabriel, and this is the New Calculus channel. Till next time, goodbye.